Hi everyone, my name is Tamil Murugan. I am the leader of this group. Let me introduce my member.
Hi, my name is Magad Muizuddin.
Hi, my name is Aidil.
Hi, my name is Putri Farah.
Guys, I heard that we want to discuss about series and sequence today.
Yeah.
Okay, wait guys. Let me introduce what is sequence and series.
What is sequences and series? Sequences is an ordered list of numbers, for example 1, 2, 3, 4. What is series? The sum of the various number of a sequence. For example, the total sum of a sequence is called as series. What's the difference between sequence and series? Sequence set of element follow a pattern, meaning while series sum of element of the sequence. Order of the element is important in sequence, but in series order of element is not important. Of sequences and series. Arithmetic progression. Every term obtained by adding or subtract a definite number. For example, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 9 minus 2 is 7, 7 minus 2 is 5. Next, geometric progression. Every term obtained by multiplying or dividing a definite number. For example, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. And when 16 divided by 2 is 8, 8 divided by 2 is 4. What is binomial expansion? Binomial expansion describes the algebraic expansion of powers of binomial. For example, a plus b times by itself is become a square plus 2ab plus b square. When a square plus 2ab plus b square times by a plus b, it's become a highest polynomial with degree 3. Pattern is summed up by the binomial theorem or Pascal triangle. This method used for the highest degree for an expansion.
Wow, that's a lot of information, Tamil. I think, Magad, don't you have a lot of information that you want to tell us?
Yeah, I can share some of the knowledge about the history of series and sequence and also binomial expansion.
The history of sequence and series. Do you ever wondered who invented sequence and series? Series and sequence were invented by Carl Friedrich Gauss, a German mathematician. As the story goes, when Gauss was a young boy, he was given the problem to add the integers from 1 to 100. It seems like a simple question, but remember that there were no calculators those days. As the other students struggled with this lengthy addition problem, Gauss saw a different way to attack this problem. He lists the first 50 terms and then lists the second 50 term in reverse order beneath the first set. You can think of it as he wrapped the series back onto itself. Added the paired values, noticing that the sums were all the same value 101. Since he had 50 such pairs, he multiplied 101 times 50 and obtained the sum of the integers from 1 to 100 to be 5050. After many changes and ideas, Gauss was able to quickly solve problems and establish a relationship that we use today, arithmetic series.
Wow, that sounds fun.
Fine. Okay, so let us discuss about some question.
Hello guys, this is the example of the PSPN question. So the question was like the ninth term and the sum of the first 15 terms of an arithmetic progression of 24 and 330 respectively. Find the first term A and the common difference D. Hence, find the least possible value n such that the sum of the first n terms is greater than 500. First, uh, we list all the information given, like term 9 is 24 and the sum of first 15 terms is 330. By using this formula, we could get the first equation, and then to use this information, we could use this formula to get this the second equation. And to get A and D, we should solve it by solve both equation and we could get the answer. So like this, I'm using this type of solving problem to get the difference, the common difference. So the common difference is 2, and after I got the common difference, by using the common difference and substitute it into the first equation, I could get the first term. After we got common difference D and the first term A, we hence find the least possible value n such as the sum of the first n term is greater than 500. So the sum of the first n term is greater than 500. By using this formula, we just substitute the A value and the D value and we got this equation. We solve it normally and we could get this quadratic equation. So by solving this quadratic equation, by expand it, we could get n is greater than 90.13 and n is greater than negative 26.13. So we take the positive value because the sum of the first n term is greater than 500. So we take the nearest number of the 19 greater than 19 and the answer is 20. So that is how you solve the PSPM question.
The next question is from PSPM 2005. The fourth term and the seventh term of the geometric series are 1/2 and 1/16 respectively. Determine the first term and the common ratio, which is A and R. Hence, find the sum of the first 10 terms of the geometric series. Sum of the first 10 terms. So first we need to use this formula for geometric series. The fourth term. So AR power of 4 minus 1, 4 because of the fourth term, and equal to 1/2. 4 minus 1 we get 3, AR power of 3 equal to 1/2. This is the first equation, and the next equation is the seventh term. AR power of 7 minus 1 equal to 1/16, and 7 minus 1 we get 6 and equal to 1/16. This is the second equation. Next we need to divide the second equation with the first one. AR power of 6 divided with AR power of 3. We can cross the A and 6 and 3 and we get R over R the power of 3. 1/16 from the second equation divided with 1/2 and you will get 1/8. Then simplify it, you will get the R is 1/2. And use the first equation and sub the R into the equation. A 1/8 because the R is power of 3, so just take it from up this one, put it, and equal to 1/2, and you will get A equal to 4. Next, for the sum of the first 10 terms, we need to use this formula and sub it in. A is 4 and 1 minus 1/2 power of 10. Simplify it, 1/2 the power of 10 you will get 1/1024, and simplify it, 4 minus 1/256 and divided by 1/2 and you will get 1023/128. This is the sum of the first 10 terms in this geometric series.
Have you ever thought in maths class, when will I ever use maths in real life? So today I'll be showing you some example arithmetic sequence and series in real life. So here is an example of an arithmetic sequence in real life. As you know, every year we have 12 months: January, February, March, April, May, June, July, August, September, October, November, and December. The months of the year is in a sequence. After January, it will always become February. It is impossible to go from March to July because it has to go in a sequence. So this is an example of an arithmetic series in real life. I know a lot of you probably watch or have watched a soccer game before, but I can almost bet on it that you haven't thought of it an example of series. In a soccer game, each goal is worth 1 point. If one of the team make their first goal, the series will start with 1. After a couple of minutes, they make their second goal, so we will add +1 to the series. If the team keep on making goals, we will add 1 for each goal to the series. At the end of the game, we will add all the terms in order to obtain the result of the game. So that's all from me.
I hope you guys understood. Let's end the discussion. Bye.
Bye.
Bye. Thank you, guys.
Thank you.